Well, hello and welcome, everyone. I'm Mark Millard and from Cal's IT, and I'll be the moderator for this session. Today we have Jared Kasanovic, who's going to present on safe and predictable team collaboration with cloud platforms, which I'm excited to hear about. We'll have time for some Q&A, but feel free to drop questions in the chat. We can come back around for those. But without further adu, I'll turn it over to Jared.
All right, thank you. Yeah, good morning, everyone. For this talk, I mainly just want to talk about some of my personal experience in my own team with using cloud platforms and modifying our processes and thinking around it. This is focused less on technology and more on team process and structure as it relates to using cloud platforms in an everyday setting. Let's get started. Some of the outcomes for this presentation: one, increase confidence when making changes and deployments. So thinking about deploying something to like a non-production environment, increasing that confidence that a successful deployment to non-production will mean a successful deployment to production. And then another outcome is just for maybe to consider using a cloud platform for a new project or task, even if it's a small one. And some of the stuff I'll be sharing today, will apply even if you don't use a cloud platform. But yeah, these are kind of the outcomes I hope to achieve. So first, I just want to jump into some definitions for how our team kind of defines the cloud in general. So we define it less as where we're actually deploying something, and more as how we can interact with it as a service. So with a cloud platform, you have the platform itself, such as Amazon Web Services or Google Cloud Platform. And every interaction, or pretty much 99% of them, are going through an application programming interface, or API, which essentially allows self-service access, either via a web console or code or like a command line interface to the cloud platform. So everything is self-service when you're using that. So compare that to maybe like a classical on-premises environment. Not all of them, but a lot of the time it's kind of a mix. You might have like a console or an API that you can interact with for maybe some services, but then maybe some other services require like a web form or email communication with another person to be able to do common tasks, such as like create a VM, manage a database, provision storage, common tasks like that. Another key difference is the focus on separate teams. So like I mentioned, I'm focusing less on technology and more on team structure. Pretty general, I'm generalizing here, but a pretty general on-premises environment will kind of lend itself to having separate teams that manage separate areas. So maybe a team for database layer, networking layer, the VM or wherever an application is running, some server somewhere, and then the application itself, like the code that's comprising an application. And a lot of the times, these will be in separate teams. And the knowledge depth with each of these areas usually requires being pretty deep. So the database team needs to have a pretty extensive knowledge of databases. Networking team needs to have a pretty extensive knowledge of that. And each of these teams are focused on different goals because of the fact that they're in separate teams and they have different key competencies. So compare that to a team that might use more cloud services. Of course, you could easily replicate the type of organizational structure you use if you're deploying applications on premises, same as in the cloud. You could replicate that same environment. But having that self-service capability, as well as some other capabilities I'll talk about, really lends itself to having a different team structure and different focus. So with the cloud, with the capabilities that it affords us, lends itself to having a single team that comprises of different competencies all within the same team. So now all these various animals are in the same team. They each have some sort of knowledge of the different key areas of their application. But then the cloud platform takes care of a lot of the other stuff. So, each team member has a somewhat more shallow knowledge depth of each of these key areas. And the cloud platform takes care of a lot of the more generic information. So team members, need to be knowledgeable for a broader range of skills, but that can be more shallow because they can focus more on the unique knowledge, the things that are unique to their application, and leave the generic or the general knowledge to the cloud platform. So, general things such as, keeping a server up, keeping a database up, those sort of generic low-level things can be kind of offloaded so that a team can focus towards a common goal, and have a broader range of skills, but still focus on a singular goal with that knowledge. Some other key differences are the pay models. So most of the time, cloud platforms are pay as you go. They have some sort of calculation for how a service is paid for, whether it's the minutes that a VM is up, multiplied by its like compute and memory, or maybe the number of requests that you're making against a service. And a lot of the times with on-premises, the payment structure will be upfront, in addition to maybe some support or licensing costs. So those are some of the key differences between those types of platforms, and now some of the benefits of using cloud platforms. The first big one is a concept called infrastructure as code. So this is a pretty big topic, but what this essentially is that, with that API that I mentioned that you can use to interact with all aspects of a cloud platform, you can configure everything in that cloud platform using something that you can store in version control, like Git, like you would your application itself. And so, and yes, Jared Balkman, there has to be a biking reference. I'll take a brief pause just to mention that I forgot to mention this at the beginning, but feel free to put comments or questions in the chat, and we'll have some time, about 5 minutes at the end, to answer questions. So yeah, thanks. Yes, it has to be a biking reference somewhere in there. Anyway, jumping back into the presentation, a very common way to configure these cloud platforms, and very convenient, honestly, is just to log into that web console that I mentioned and kind of start to click around and set things up to be able to deploy an application. This is a pretty fast way to get things going, and it's a good way to learn. But the problems arise when you need to make changes, or maybe need to roll back changes. How do you know what was changed? And then when you start thinking about different environments, so production environments and non-production environments, how do you know that those two environments are in sync if everything was configured like in a web browser, in a user interface? This is kind of where infrastructure as code comes in to help. So like I mentioned, it's an alternative to managing cloud resources via that console user interface. And what it's doing is that you're declaring which cloud resources you want to create, and manage within configuration files. And it's declaring the state of what those resources should be. So a lot of the tools out there, one tool is called Terraform. You can declare what a resource should look like, and it will take care of the changes, the creations, the deletes, the updates that need to happen in order to make your cloud platform resources match your intended state in your configuration files. So it's stored in version control. This is helpful for, like I mentioned, tracking changes to your infrastructure. And it also helps keep your application in sync with your infrastructure, because if you're managing your cloud resources alongside your code that you're running, for example, whether it's Python or C# or whatever you're using, you can keep those things in sync. You can know, hey, I made this change to this cloud resource and this change in my application at the same time. this is all one unit that I can deploy, which helps from preventing things, getting out of drift. And like I mentioned, these infrastructure as code tools will take care of the creating and updating and deleting, and they'll also take care of dependencies. So they'll know if you're creating multiple resources and one needs to be created before the other is, it will know that, and it'll be able to deploy things in an order that makes sense. It will also know if a change can't be made without deleting something and then recreating it. So it takes care of that for you as well. Another aspect is disaster recovery. So think about all of the work that we would put in a cloud platform to configure it to run in our application. If something were to go wrong, or maybe we need to, create a whole new account for a cloud platform, we aren't storing any sort of state in that. Everything is in version control, in infrastructure as code. We can easily deploy our entire application to a brand new account, or org or wherever it might be in the cloud, if we need to. Here's an example of what infrastructure as code might look like. This example is creating a S3 bucket, essentially an object storage bucket in Amazon Web Services. You can see it has a name. My TF test bucket has some tags just to label it. And this is a pretty simple example. This will take care of creating that bucket in the cloud. And if I were to add another tag, it would know that that's an update that needs to be made in the cloud, and it would make that change. Some more benefits continuing along here. So when we're using infrastructure as code, we get the benefit of ephemeral non-production environments. So what I mean by that, we can compare it to maybe a more traditional application architecture here, where we have a production environment and a few non-production environments, such as dev and test. One thing that can happen is that, if we have multiple team members working on these environments, conflicts can happen where, one person is trying to deploy a change that might affect another person's change. So they need to kind of coordinate on that. Another aspect is that, these environments are usually running all the time, and incurring cost. This might not be a big deal in on-premises, but when we're talking about the cloud, like I mentioned, it's pay as you go. So if there are environments that are running all the time, even if we're not using them, they can sometimes incur costs depending on how they're deployed and what resources or services are being used. So if we're using the cloud and we're using infrastructure as code, we know the exact configuration that our application needs to be. So what we can do is deploy essentially ephemeral non-production environments as we need them. And as many as we need as well. We can obviously change parameters to make the non-production environment smaller and incur less costs, but otherwise things can stay pretty much the same, and we can make changes in these ephemeral environments, and then when we're done, infrastructure as code, we can just destroy all those resources that we created, and we know what changes need to be made to the production environment. So this is helpful, getting back into like team process. This is helpful to kind of reduce coordination between team members, have isolated environments that people can use to test their changes. Continuing along here, to some smaller aspects, self-service, fast feedback. These are things that are afforded when we use cloud platforms because of the API. We aren't waiting for someone to get back to us. We can make a request, create a resource, make a change, and we instantly know whether that was successful or if something went wrong. And if it went wrong, know what we need to do to correct that. Another nice aspect is how widely known these platforms are. So we can, with the easy Google search or even ChatGPT, you can do some research and maybe solve a problem. Chances are someone online somewhere has solved this, the same problem that you have in a cloud platform before. So that's another helpful aspect. Related to the pay-as-you-go model, Another nice aspect of these platforms is how well they document quotas and limitations. So, if it's storage, document maybe the maximum, size of a file you can upload, or if it's more of like a web service, like document how many requests per minute you can make to that service. So these are all helpful for managing an application, because we can tie these back to business events. So for example, if we know my group manages course search and enroll, so we the application used by students to kind of plan their schedules and register for classes. So if we know or if we can expect how many students might be logging in on a given day to register for a class, we can tie that usage back to the usage of our cloud platforms and know whether the services we're using will be able to handle that traffic. It kind of takes the guesswork out of doing that. We don't need to hope that things might work. There's obviously dependencies involved, but when using cloud platforms, it's kind of easy to know, hey, my application will be able to handle this amount of traffic or not, because those limits are documented. So let's taking advantage of some of these benefits. That wasn't meant to paste all at once, but bear with me here. We'll just go from top to bottom. So the first thing we can take advantage of is thinking about how safe it is for a new team member to make a production change. And when I mention safety, I'm talking about what are the sort of sharp edges that people need to be aware of when they're making a change to an application. How easy is it for someone to come in on day one and make a production deployment? What things do they need to be aware of? Like, what implicit knowledge have they not learned yet to be able to do that? And what sort of confidence do we have in those production deployments? Like, if we have a successful deployment to a non-production environment like dev or test, how confident are we that that will also be successful to production? Some of the things we can do is document some of those things. So kind of remove those sharp edges. Another thing that we can do is take advantage of infrastructure as code. Like I mentioned, this will take a lot of the guesswork out of knowing whether a non-production environment matches a production environment, because the state of that is all documented in our code. And if there are any differences, those tools will help identify that. It's something called infrastructure drift. Another thing we can do, more of a technical control than, say, documentation, is implement automated testing. So thinking about, what are those sharp edges that we need to be aware of, and use automated testing to, get rid of those. What are some things that maybe a more experienced developer knows they need to check before they make a change in production? Let's first document what that is, and then even better, write a test so that we can check and stop a production deployment if that test didn't pass. So using infrastructure as code, implementing automated testing, these are all things that we can do in version control, and these are all things version control platforms will help do in an automated pipeline. So, being able to run a series of steps to deploy our application, test it, and then maybe deploy it again, this time to a production environment. And then another aspect these platforms help with, especially GitLab, GitLab being a version control platform, kind of stepping away from cloud platforms for a second, is their tools such as merge requests. So a tool that helps make changes, helps teams collaborate on changes by seeing what exactly is being changed, and then maybe providing feedback or comments on things that might need to be improved. So that's kind of where I'm going to go now, is jumping into an example of how our team uses merge requests to make changes to our applications and provide feedback on those changes as well. So I'll jump into this tab, zoom in a little bit here. So this is GitLab. This is where Our team manages our applications. This is version control. We store all of our code here. We store our application code as well as our infrastructure. So our infrastructure as code is stored here as well. Documentation as well. So this is for our project for the person API. This is where we store all the code for that. And this is what we're seeing here is an example of a merge request where we're making a change to the person API, and we're providing feedback and testing that change. So the first thing I'll share here is that this is a pretty big change. We're changing a lot of code here, and we're also changing infrastructure as well. So the person API is written in Python, so we have some. So the files on the left here are the files that are being changed. So we have some Python files. And then scrolling down, we also have some Terraform files, some infrastructure as code being changed. So for example, let's jump into a different change here. So all the green is stuff that we're adding. We're adding a new, we use Google Cloud Platform for the person API. So we're adding a new function here, and storing some of the configuration for that. And these are all things that we use as a team to review the changes that we're making before we make them. So that's the kind of the human aspect of it. We're able to kind of browse all these files being changed before they're deployed to production. The other thing we can do is provide feedback on those changes. So specific lines that are being changed, excuse all the scrolling here, but we can go down and see comments on those changes. And then as those comments are being made, kind of see, it's kind of a timeline, see all the changes that were made in response to the feedback. So for example, one of our team members, Shrey, made a comment. Wes responded, and then that comment was resolved. So that's kind of how we use this as a tool for collaboration. The final thing I'll show here, and again, apologies for the scrolling, is that automated pipeline that I mentioned. So every time we create a merge request, we're making a request to make a change. We have a series of steps in our pipeline that run to test that change and make sure it's successful. So I'll go into that here. I won't go through all of these. I think one of our team members, Wes, actually has a more in-depth pre-recorded presentation on this. So I definitely encourage you all to check that out. But just as a basic overview, what's happening here is, we're running all these validation steps. We're deploying this to a dev environment. This particular project does not use those ephemeral environments that I mentioned, but a few of our other projects do. We're deploying that to dev. We're doing some database work, and then we're doing some post-deployment tests. So if any one of these tests fail, this will kind of stop the pipeline, and it'll be really clear, that we cannot make this change in production because something failed along the way. So this is kind of how we, remove those sharp edges to deployment of a change. I would be very confident in a new team member to be able to make a production change in the person API because we have so many of these tests. There would, and it's also a good learning process. Let's say someone, a new team member did make a change and it passed all the tests, but there was something missing that we need to take care of before deploying to production. Well, that would be a good thing to test in the future. So having new team members, make changes is a really good way to kind of expose those sharp edges that maybe more experienced team members might not be aware of because they do it, implicitly or unconsciously. All right, and with that, that was kind of all I had. So yeah, thank you for listening. And does anyone have any questions?
Jared, thank you for the presentation. Enjoyed hearing your thoughts about it. And as always, I like seeing GitLab, but it was really well put together. I like the transitions in the slides, the information. Much appreciated.
Thank you.
Yeah, super informative, Jared. Thank you. Just don't see any questions in the chat at the moment, but folks can feel free to open up their mic or drop a question in the chat.
Jared, I think to be honest, I'm still processing information, so it was good.
Oh yeah, no, absolutely. I'm definitely around for questions, but no expectation that people have questions on any of this.
Oh, my video did turn on. Hey, Jared. I was curious. I missed like a few minutes of the first part, but I was wondering with the cloud hosting that you do, do you all do that through like the public cloud within Do It? Public cloud? Okay,
yeah.
Cool. I was wondering like what that experience was like setting something up. I have never set up anything within, like I've done just an S3 bucket once. But I was wondering kind of like how you got started learning all of it, if that makes sense. Sorry if you covered that part in the beginning though.
Oh yeah, no, that's a really good question. Honestly, I think like your example, S3 bucket, like that was maybe the first service that I used in Amazon. And for a while I, was just kind of clicking around in the web console and in Amazon Web Services. I mentioned the importance of infrastructure as code, but the nice thing about using that UI is that it's a really good learning tool. It gives you really fast feedback. So there's definitely no shame in doing that. It's definitely a good learning platform. So that's kind of how I got started using that, and then discovered infrastructure as code kind of when things started getting out of hand with the number of resources that we need to manage. Like with the person API, I think we have.
Oh yeah.
Actually, it's funny. Terraform will be able to output like a big dependency graph of like a graphic of all of the different resources you use and aligns for their dependencies, and it's pretty insane with the person API. It's probably over like 50 unique services or resources we use. So that's where infrastructure as code comes in handy to start managing all that for you.
Yeah. Was some of that stuff like new to you when you were starting? Were you kind of like challenges were just coming up and you're like, okay, I'm going to learn how to solve this thing? You're sort of taking it as it went, or did you kind of architect stuff really far ahead in advance?
I would say kind of taking things as they went. I think I was pretty lucky with some of the things that I originally used to learn cloud platforms because they didn't need a lot of services. It was like a simple API. I didn't even have to manage a database that was managed. We had to use an on-premises database, so we just connected to that. So it really helped to have a more narrow focus on like, hey, let's just focus on like one or two services and get really good at those. So I was probably pretty lucky that the problem I had to solve for my job didn't require me to kind of take on a whole load of information at once. So that was helpful.
Cool. Thanks. This was a great talk.
Yeah, thank you for the questions.
I had a question regarding the workflow which you showed at the time of deployment. So you had those test cases, right? Like before the deployment where the validation process. What are those like different tests you have written which runs before deployment? The validate?
Yep, exactly. Yeah, these are validating different areas of our code. So I'll just mention a few. Like we have, this is for the person API, we have an API specification. The people know how to interact with it, and we have we have a validation of that specification, like validating that the examples match the schema that we've documented. And then we actually, I won't jump into that now, but then we actually have another test related to API spec at the end to validate that the API is behaving how we have documented to behave. So these are validating different areas. A lot of the ones are checking our Python code. And then like the ones at the bottom are testing, running unit tests, running integration tests.
All right, sounds good. Thank you.
Yeah, thank you.
Interesting. Great. Well, thank you, Jared. So we're at 10:30, and I'm sure Jared has opened up other questions if you want, Phil, want to email him. But thank you for joining us and enjoy the rest of the conference.
Thank you, everyone.